Hey everybody, this is Mr. Longo, and we're going to talk about graphing cosecant and secant waves, but they're not really waves. So here's the thing. If you know how to graph sine or cosine, you already pretty much know how to graph cosecant and secant, because that's the first step. You have to do that part first. So here's the thing. We know that cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. So if we think about reciprocals, we're going to graph a normal sine wave, and then we'll think about what a reciprocal of each of these terms is. So when we're graphing this, we know that we have an amplitude of 1. So we're going to have a line 1 up and 1 below, because there's no vertical shift. We're just doing the parent functions, okay? Now what I'm going to show you to do is just graph sine x like you normally would, except for we're going to make it a dashed line. So we would be at pi over 2, we're going to be up at 1. At pi, we're back at 0. At 3 pi over 2, we're down at negative 1. And once you get to 2 pi, you're going to start all over again. So this is a typical sine wave. But now think about reciprocals. What's the reciprocal of 0? Undefined. What's the reciprocal of 1? It would be 1. But what if somewhere along the way, like when sine of pi over 4, we know the sine of pi over 4 is root 2 over 2. So if we were to take the reciprocal of that, we would have a number that's bigger than root 2 over 2. It would be root 2. Which is bigger than 1. What if we were to do the sine of pi over 6? The sine of pi over 6 is 1/2. So the cosecant of pi over 6 is 2. So when we're working with sine waves, our biggest value is going to be 1. But when we're graphing cosecant and secant waves, that's going to be our smallest, because the reciprocal of everything smaller than 1 is going to be bigger than 1. The reciprocal of 1/3 is 3. The reciprocal of 1/4 is 4. The reciprocal of 2/3 is 3/2. So this is our typical sine wave, but you have to remember the reciprocal of 0 is undefined, because 1 over 0 obviously can't be done. So here we go. Here's our normal sine. To graph cosecant now, all you have to do is everywhere you are touching the node, in this case it's the x-axis, you now have a vertical asymptote. The reason you have a vertical asymptote is because those terms are undefined. You cannot divide 1 by 0 once you take the reciprocal. And then everything else is just the reciprocal of the graph. So what's going to happen is you're just going to go like this. Okay, because like I said, the reciprocal of 1/2 was 2. So you're going to be up here instead. And even as you get all the way close, the only thing you're going to do is reciprocal of 1 is 1. So this is how you graph a cosecant wave. All you have to do is graph sine in a dotted line, and then anywhere you hit the node line, you draw a vertical asymptote, and then you just pretty much flip the wave that you see in that section. It works the same way for cosine. So for cosine, again, there's no vertical shift, so we still have our x-axis as the node. We have a crest and a trough at 1, because our amplitude is 1, but cosine starts at the top. So cosine starts here, comes down, goes down to the bottom trough, back up, here we go. So here is our parent function for cosine. So if we were going to graph secant, we're going to do the same thing. Anywhere we have a dot that's touching the node, we are going to have a vertical asymptote. And then to graph secant, it's just the reciprocals. So this section is going to be totally flipped upside down. And this one, we're just going to go up to there because we're not going to go back that way past one term. And same with here. The reciprocal of 1 is still 1, but we're going to go this way. And our lines will never cross the vertical asymptotes. Remember, that is the whole point of them. So like I said, you already know how to graph sine and cosine. All you have to do is do that part first. And then you just have to draw some vertical asymptotes and graph upside down. So here's 2 for you to practice. One cosecant in radians, the other one in degrees. Really, it doesn't matter if it's radians or degrees, you just have to know how to graph it. So why don't you pause the video, try both of these on your own, and see if you know what you're doing when you click play. Give it a shot. Alright, so let's see how you did. So obviously we know we have an amplitude of 3 and a vertical shift of -1, but we also need to figure out what our period is and our interval and all of that. So we still have our 0 is less than or equal to 1/2 of x minus pi, which is less than or equal to our standard period for sine, which is 2 pi. And then of course we multiply both sides by 2. And then add pi to both sides. And our range is going to be from pi to 5 pi. Now remember, our period is 4 pi, so we divide that by 4. And our interval is 5. So the first thing I'm going to do is kind of lay out what we need here. So obviously we're going to have our standard 5 tick mark line. And then first thing I'm going to do is go down 1. Now that's my node again, just like we did back in the day. And then I'm going to go down 3. And up 3. That's going to be my crest and trough. And then we're just going to graph the wave. So remember, this is from pi to 5 pi. So we have our pi, 2 pi, 3 pi, 4 pi, and 5 pi. And since this is a sine, it's a reciprocal of sine, we're going to sketch out sine, which normally starts at the node. And since it's positive, it goes up to the top first, back down. Here we go. And then you really don't need to sketch out the whole wave if you don't want to. Now what we need to do is put our asymptotes. So you should have an asymptote running at all of the points that hit the node, because that's where they're going to be undefined. And again, you didn't really have to sketch out the other part because we know we're just going to flip it over for the reciprocal. So this one is going to be right there. And this one is going to be right here. Now, if you want to do the whole wave in dashed lines, you go right ahead. That will be helpful to you. Do it, okay? But, you know, you are going to need a little bit of extra space because of the fact that nothing's going to be in the middle anymore. That's just where our sine wave used to go. But now we don't need that, okay? So before I do the second one, I'm going to just scroll it down a little bit so we have a little bit more room. But then we're going to do the exact same thing. So if you didn't try this one yet, pause it and give it a shot on your own. And then as soon as you're ready to see the play-by-play, click play and we'll see how you did. So again, let me just move this down a little bit so we have more room. And go ahead and give it a shot. All right, let's see. So basically what we have this time is we have another one of our, of course, 5 tick mark lines. And we have to find some information. We do know that we're going to have a vertical shift of up 2. So here's our node. And then, of course, our amplitude is 1. So we've got a real small graph right here. We're just going to go up 1 and down 1. And then we have to, of course, set our inside. So we have our 0 is less than or equal to 3 times theta plus 90, which is less than or equal to 360 this time. Divide both sides by 3. And we have 0 is less than theta plus 90, which is less than or equal to 120. Subtract 90 from all sides, and we have negative 90 is less than or equal to theta, which is less than or equal to 30. So this guy, we're going to start at negative 90. Our interval is a period divided by 4, so we're going to be going up by 30s. So we have negative 60, negative 30, 0, and a positive 30. So we have our y-axis right here. And then we just have to sketch out what would typically be our negative cosine. So negative cosine starts at the bottom. And then, of course, we would just follow our pattern. And then again, if it helps you, sketch it out. If it doesn't, then all you have to do is put your vertical asymptotes on our node line points. So we have our node line points right here. And then everything else is just a reciprocal. So this guy would typically go up this way, but now we're going to go down this way. And this guy is going to be the reciprocal over here, so we're going to go like that. And then this guy would typically be going up from this way, but now we're going to start here and we're going to go down. Okay? And that's graphing the reciprocals of sine and cosine. This is Longo and I'm out. See you, bye.